Hi, welcome to Our Math. Today I'm doing a series of videos on exponential functions. In this, we have an application. It says the half-life, and half-life tends to be tricky for a lot of students. The half-life of cobalt-60 is about 5 years. Suppose we have a 200-gram sample. Find a function that models C of x of cobalt-60 remaining after x half-lives. If you're given variables, use those. All right, C of x equals exponential function. You always start with your initial sample, which is 200 grams. Half-life just tells you we're multiplying by 0.5 each time. Half-life can be the simplest function to write because it literally says replace a, let's see, f of x equals c a to the x, where this is your initial and this is your factor. And half-life is just, hey, your factor is 0.5. You don't need to do 1 plus, you don't need to do 1 minus, you don't need to do anything special. If you really want to think of this as a decay of 50% and you have 1 minus 0.5, you can do that, but really for half-life, you should just set a equal to 0.5. It says use the model to predict the amount of cobalt-60 remaining after 35 years. Well, this is in 5-year chunks, so I need to take that 35 years, divide by 5, and realize that the half-life is going to happen 7 times. Well, C of 7 is 200 times 0.5 to the 7, which is 1.5625 grams. Okay. Next it says make a table of values with x varying between 0 and 5 and graph. All right, so we start with 200. After 5 years, because that's what x is in, there's 100 grams left. After 10 years, because again, that's what x is 5-year chunks, there's 50. After 15 years, there's 25 grams. After 20 years, there's 12.5 grams. And after 25 years, there is 6.25 grams left. All right, and then graph with labels. So this is, we'll just say cobalt 60. This is 5-year chunks. So 1, 2, 3, 4, 5. I could separate this more and go 1, 2, 3, 4, 5, but we'll keep it like this. Let's see, 200. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go up by 20. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, and this is cobalt 60, and we'll put G in parentheses so we know that the label is grams, and we have all of our information on our graph. So we start with 200. After a year, we're down to 100. Then we're down to 50, then we're down to 25, and then we're down to 12.25, and then 6.25. And this is a very, very traditional look for an exponential graph. The thing about, make sure you put your arrow. We don't need an arrow on the side because we started with 200 grams. The thing about exponentials is we'll get closer and closer to this axis, but we'll never touch it. We cannot use this equation to get to 0. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.